Static routing. What is static routing? Static routing is to specify the associated gateways explicitly for the network traffic to a specific subnet. Manually adding a route entry is known as static routing. On the hand, using OSPF, RIP, BGP, or other automatic methods to exchange the routing tables with other routers is known as dynamic routing. For example, if traffic to the network 172.16.9.0/24 should go there via 192.168.1.12, then you need to specify it in the routing table so that the traffic can be forwarded to the right place. And this can be set via a system network static routing. Example, add route to other subnet via gateway. How to add a gateway for a specific subnet? In the diagram above, the local network behind the firewall is 192.168.11.0/24. However, there is another network 172.16.9.0/24 behind a gateway. GG is with two Ethernet interfaces, one is with IP 192.168.11.10, the other is with IP belonging to 172.16.9.0/24. Thus, if we want to have the traffic from 192.168.11.1 to travel to the network 172.16.9.0/24 via G, we need to set as follows: destination network, 172.16.9.0 netmask, 255.255.255.0 gateway, 192.168.11.10. Please notice that this gateway for a specific subnet is not default gateway in general, this is the gateway to the 172.16.9.0/24. Furthermore, doing the setting as above does not guarantee your network communication between firewall ETH1 and Anther server behind the gateway, denoted as A, will be running smoothly. It also needs to have the similar setting in a such that it will know the network 192.168.11.0/24 is behind the gateway G correspondingly. As shown in the diagram, host A needs to set its gateway to 192.168.11.0/24 as 172.16.9.1. So, the traffic from firewall to A can have the correct route for the response packets issued from A. By the way, the list of routing entries of routing table in the screen, system network static routing, can provide hints when you try to perform diagnosis for network issues. Once this side is checked, you also need to check the other side to see if the packets can be passed to the system. The routing entries exchanged via OSPF or RIP v2 will also be listed here. This is the main routing table of the system. OSPF and RIP v2. In contrast to static routing, there exists dynamic routing as well. Static routing is to adding route entry manually, whereas dynamic routing is to use routing protocols like OSPF or RIP to exchange the routing information with other routers and update the local routing table accordingly. Thus, you do not have to add the route entry one by one manually. Large networks are using BGP, Border Gateway Protocol, to perform this task. Here we only introduce OSPF and RIP v2. We use the following diagram to explain how OSPF and RIP are introduced into the system. Assume the router A is connecting to three subnets, 192.168.1.0/24, 172.16.9.0/24, and 172.16.12.0/24. Router B is connecting to 192.168.1.0/24, 172.16.13.0/24, and 172.16.14.0/24. What if a host in the subnet 172.16.14.0/24 wants to reach another host in 172.16.9.0/24? In the previous section, we know that we can add a static route in router B by specifying the gateway to 172.16.9.0/24 is 192.168.1.1 and add another route in router A that the gateway to 172.16.14.0/24 is 192.168.1.2. How about the other subnets that router A and router B connect want to reach each other? Of course, we can add static route rules one by one. But that process is error-prone when you try to add many static routes. We hope that the routing tables on router A and router B can exchange with each other so that they will know which subnets they are directly connecting to. This is how RIP v2, Routing Information Protocol, version 2, and OSPF are introduced. In the example above, we just ask both router A and router B to send route update to the subnet 192.168.1.0/24 so that they will learn the routing table of each other. To use RIP v2 or OSPF, just navigate via System Network RIP or System Network OSPF and specify the subnet you would like to announce the existence of RIP v2 or OSPF so that the other router running the same protocol can respond it and exchange routing information. Please note that this subnet has to be the network that this router directly connects to. After the route update is stabilized, you will find out the number of routing entries shown in System Network Static Routing is increased. For example, To use RIP v2 to announce the root update on the subnet 192.168.1.0/24, just navigate to System Network RIP and set the following fields: network, 192.168.1.0 net mask length, 24, and press Add button, then click checkbox on the right to enable RIP. To use OSPF, Open Shortest Path First protocol, you also need to set area ID for each subnet. It depends on how you partition your network. If there are multiple areas, one of the areas must be 0, area ID 0, and it is known as backbone. For simplicity, we can just have one area by setting area ID to 0 for every subnet. For example, on System Network OSPF, set network, 192.168.1.0 net mask length, 24, area ID, 0, and press Add button. Then check the box on the right to enable OSPF by pressing Submit button. For some routers, they might require authentication for exchanging routing table information. In this case, we need to turn on authentication mechanism for OSPF. OSPF Authentication. OSPF Authentication is used when the routers need to verify if the routing status should be exchanged with other routers or not. Navigate via System Network OSPF Auth to set OSPF Authentication. You should specify the Ethernet interface for using OSPF Authentication and determine if the authentication key should be hashed, using MD5 algorithm. Ethernet interface, ETH3 authentication key, GoGo 123. If MD5 is needed, please click the checkbox Enable Message Digest. And do not forget to activate the authentication on that area. Assume the subnet belonging to ETH3 belonging to area 0, just use area ID 0 and click Enable Message Digest if it is needed. After it is set, it is necessary to restart OSPF process. PIM, Protocol Independent Multicasting, in IPv4, 32-bit IP address, Class D IP addresses, 224.0.0.239.255.255.255, are reserved for IP multicast. For details, please refer to IETF RFC 1112 or the derived documents. We only give a short and quick review here. The word multicast in IP network is different from broadcast. It implies the scenario that a group of hosts join a multicast group and receive multicast packets destined for this multicast group. In other words, for all the hosts in a multicast group, each of them is carrying at least 2 IP addresses. One is its original IP address for unicast, the other is the IP address for this multicast group. For any network packets with destination matching the 2 IP addresses, this host should receive those packets. And a host can leave or join any multicast group at any time. When to use PIM? Consider the scenario: hosts with the same multicast group can reside in different subnets. In other words, the receivers of multicast packets can be sitting in different subnets by receiving the packets destined for the same multicast group IP address, and this scenario will not happen in unicast. Multicast routing protocols are used to deliver multicast packets across subnets. There are several multicast routing protocols like DVM-RP, based on RIP, MISP, based on OSPF, and PIM, Protocol Independent Multicast. In this system, we support PIM v1 and v2 only. If all the receivers of a multicast group reside in the same subnet of the multicast sender, it does not need multicast routing protocol supported in network equipment, it only needs IGMP, Internet Group Management Protocol, support. In other words, for multicast to work well, it needs IGMP support within a subnet and it needs the support of multicast routing protocol, DVM-RP, MISP, or PIM, to go across to another subnet. We do not want to go into details for introducing PIM here. For details, please refer IETF RFC 3973 or other literature to know the functions of DR, designated router, RP, rendezvous point, candidate RP, and BSR, bootstrap router. We only describe what should be noted here. To use PIM, navigate via System Network Multicast Routing and enable it directly. When PIM is started, it will specify all the subnets it should receive/send multicast packets. Usually, those are the subnets that the machine is directly connected to. In other words, it will drop the multicast packets that senders do not belong to those subnets. If you want these types of packets to be delivered, you need to specify additional network for the sender resides and the associated Ethernet interface that the packets will be discovered. This usually happens when multiple multicast routers are cascaded together. For example, ETH3 is within the subnet 172.16.12.0/24, but some multicast packets from 172.17.1.0/24 will arrive at the subnet and we wish the multicast protocol PIM will handle those packets as well. At this time, on System Network Multicast Routing, we set additional network, 172.17.1.0 net mask length, 24 interface, ETH3 and press Add button. After that restart PIM. For the Ethernet interface you want to avoid direct multicast from PIM, you can specify System Network Multicast Control. For example, We do not want ETH3 to join PIM, then we set interface, ETH3 and press add button, restart PIM. And the rendezvous point can be manually set by specifying its IP address. Rendezvous point is the entity that the packets of multicast senders will reach to this point, and the receivers of the multicast packets will obtain the packets from this point. Usually, the system will select it automatically, you do not have to set it manually.